All right, 7.1 is talking about trigonometric identities. Trig, you're going to be talking about sine, cosine, tangent, that sort of thing. We're going to be doing proofs. You guys remember proofs in geometry? We have two columns, and you got to, left-hand side's got to equal the right-hand side. We're going to do the same thing, but we're going to do it with trig identities. It is not the most fun thing in the world, like every other day in math is for you guys, I know. But it's not horrible. Like I said, you'll catch on to it. You'll start to see some things that kind of make sense a little bit, I promise. This next slide right here, you guys, everybody should take a screenshot of this. All of this. You should take a screenshot of all of this. And every single problem you do, homework-wise, anything, you should have that next to it. You will be given this on any assessment. We do this in pre-cal, and everybody gets all of the identities. But what you need to understand is we're going to be replacing, like when you see secant, you're going to replace it with 1 over cosine. When you see tangent, you're going to replace it with sine over cosine. We're going to simplify and we're going to prove. What does it mean to simplify? You simplify something. You simplify your life. You make it what? Simpler, smaller, easier. All right, so that's what we're going to do. We are going to use these identities, and you'll see what I mean in a second, to simplify. What you need to understand and remember is that the most basic, write this down, most basic trig functions, or simplest if you want to say, simplest trig functions, are sine and cosine. Keep that in your mind. When you are trying to simplify or when you're trying to prove one thing, you want to try to turn things into sine and cosine. You'll see what I mean by that in a second. Now, the second thing I want to bring to your attention is our Pythagorean identities. When I think of the word Pythagorean, what do you guys think of? Pythagorean theorem, a squared plus b squared equals c squared. Look, if you notice these identities, they all have something squared, right? And they all have a plus 1. Anytime you have something that has a trig function squared and a plus or minus 1, that's where your eyes should go, to those Pythagorean identities. So let's just go ahead and start working on some problems. These odd, even identities and cofunction identities, you guys can see it. That's it. I'm not doing anything else with it. Let's go here to simplifying, all right? Here is my problem. This is the problem that we're trying to simplify. We're trying to make it smaller. All right, the first thing you should do is to take your identities, put them here, right in front of you so you can see. Okay, we are trying to take cosine t plus tangent t sine t and make it as simplified as possible. What did I just tell you guys was the most basic of our trig functions? Cosine and sine. Good. So we're going to go through and we're going to try and change all these to sines and cosines. I see I'm adding and I'm multiplying. Do you see how tangent and sine are being multiplied together? Okay, I'm going to change the t to an x because I don't want to get anybody confused. But I'm not going to simplify cosine because it's already pretty simple with cosine. So I'm just going to write cosine of x plus, what am I going to simplify tangent to? What can I change that into? Look at your identities. What can we change tangent into? Sine over cosine. Okay, I agree. I'm going to put a sine x over cosine x because when we simplify, we're trying to make things as small as possible. And our most basic trig functions are sine and cosine. So all we did was just replace sine and tangent with sine and cosine. And then I still have times the sine of x. Everybody okay with that? Right, now we're just going to follow the rules of math. I still have my cosine of x plus, if I have y times y, what does that give me? Y squared. Here I have sine times sine. What do you think that gives me? Sine squared. So I'm going to rewrite this as sine squared x. We're just simplifying. We're cleaning it up. Now, if I had a fraction over here, if I had 5 plus 2/3, and I said to you guys, add that, what would you do first? You'd get a common denominator, right? All right, same thing happens when we're using trig. What is underneath cosine of x on the left-hand side? There's a 1 there, right? So if I'm going to get a common denominator between cosine x and 1, what would it be? Cosine x. Okay, I agree. Good. So this already has cosine of x. So I'm just going to keep the sine squared x. What does this one need? It needs a cosine of x. So what you do to the bottom, you do where, guys? To the top. Perfect. So if I'm going to multiply those two together, what's cosine times cosine? Cosine squared. Awesome. So I have cosine squared x, and there's a plus in the middle. All right, now we're trying to simplify. Simplify means to make what? Smaller, simpler. This doesn't look super simple to me. It looks like I complicated it more, but I didn't, because we're trying to change everything into our most basic functions, which are sine and cosine. So let's look back at our identities. All right, I can't simplify cosine. It's not going to help, but can I do anything with this numerator? Look at the numerator and then look at your identities. Where does your mind go when you look at your identities? I have cosine squared x plus sine squared x. Does anybody see anything? One of our Pythagorean identities. So I can replace cosine squared x plus sine squared x with what number? Perfect. I can replace it with the number 1. So this is 1 over cosine of x. Now let's look at our identities. That's pretty simplified from what we started with, right? But can I make that one step simpler, one step prettier? What could I rewrite 1 over cosine of x as? Say it again. You're right. Secant of x. And that is our simplified version. We went from this big yucky thing in yellow to this beautiful little one term of secant of x. All right. This is a whole bunch of blah, 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 blah that I don't even want to. Let's look at this for a second. When you're proving, I will tell you guys to start with one side. Don't try to do two things at one time. It says use known identities. Just use what you've seen before, what you know, the rules of math that you know. And like it says right here, you want to try to convert to sines and cosines. That's our most basic. You always want to think in terms of sine. Bother you guys with, all right? Cosine. So this is what I was talking about. We are going to have a proof, okay? So first thing I'm going to do is rewrite the problem. It says cosine of theta times secant theta minus cosine theta equals sine squared theta. All right, so first thing I'm going to tell you to do is put our identities in. Okay, I'm going to put my identity right here. Now, at the end of this problem, it should say sine squared equals sine squared. That's what we're looking for. Remember in geometry, we did this like a 2-column proof, right? Super fun. This is the worst thing in the world to me. I hated this. All right, so we look at this and we say, all right, which side looks more complicated? That's the side you want to try and simplify. Which side looks like there's a lot more going on? The left-hand side. All right, so let's just take it piece by piece. First of all, cosine, that's pretty basic. I'm going to leave this as cosine theta. Now I see a secant. Well, what can I change secant into using my identities? What is secant the same as? Good. 1 over cosine theta. Good. Perfect. Then I have minus cosine theta. And what's that over? Over 1, right? Now, I can't just go ahead and cross off cosine because I have this minus sign in the middle here. If it was just one term, we'd be good to go, but we can't. So let's leave our cosine theta out here. Now, I'm subtracting fractions. That means I have to get a what? A common denominator. Good. We're going to use our same math rules that you guys have used 100 times. You're going to start to see things repeating themselves. What's a common denominator between cosine theta and 1? Cosine of theta. Okay, agreed. So I have cosine theta. Now, I need both of my fractions to be the same. So this one already has the cosine of theta. I can rewrite the 1 minus, what does the denominator need on the right-hand side? What does this need? It already has the 1. What does it need? the cosine of theta. So if I multiply the bottom by the cosine of theta, then I do what to the top? Okay. What's cosine times cosine? Cosine squared. Okay, good. You guys are doing awesome right now. I know some of you are like, huh? Okay, now that I have one denominator of cosine theta, what can I do with those cosine thetas? Yeah, absolutely. We can cancel this. This one goes away, and this one goes away. So I'm left with 1 minus cosine squared theta. And on the right-hand side here, we haven't even touched it, but I have sine squared theta. Now, I want these two things to be exactly the same. I want everyone to look at this. Look at what we have. We have a 1, we have a cosine squared theta, and we have a sine squared theta. Let's look up at our identities. Do you see any of those Pythagorean identities? And I went there because I have something squared and I have a plus or minus 1. Do you see anything in those identities that has a sine squared, a cosine squared, and a 1? Right? This one right here, correct? You're going to use this identity a lot. So I'm going to rewrite that off to the side here. I just want to look at it for a second. It says sine squared theta plus cosine squared theta equals 1. What can I do with the one in yellow? How can I manipulate that to help me out here? I'm trying to get my function to say sine squared theta. Look at the yellow one. How can I isolate sine squared theta? What would I have to do? Perfect. Good. If I subtract cosine squared, do you guys agree with me that this now says sine squared theta equals 1 minus cosine squared theta? You agree? So this right here, this 1 minus cosine squared, I can replace it with what? Nope. What does it equal? 1 minus cosine squared theta. What does it equal? So could I write now sine squared theta equals sine squared theta? Is that a true statement? Yeah, those things are equivalent. So you guys just proved to me that this thing in red, this gross thing in red, cosine theta times secant theta minus cosine theta equals sine squared theta. You just went through the steps to show me that. This right here that I just circled is not my answer, guys. The meat in the middle is my answer. Some of you are this is gonna click. Some of you it's not going to, but let me explain something to you. You can't write down the problem like cosine theta, secant theta minus cosine theta equals sine squared theta. And then go, okay, well, I know at the end it's supposed to say sine squared theta equals sine squared theta. And then you just write a whole bunch of nonsense in here, like from your identities, and then go, okay, she'll never know. Okay, she'll know. I will painstakingly want to put a pencil in my eye sometimes as I go through this, but I will check your work to make sure it makes sense. Don't just write like every identity at the top and be like, well, she's not going to look. She's going to look. I promise she's going to look. She's going to take the time. I promise. Now, some of you are going to say, well, it's not so bad. And then as soon as you go to start it on your own, you're going to be like, what? That's that step we got to get over. I can't always tell you the first step. That's the part, and it gets better with practice, I promise. But it's not horrific. Let's try one more, and then I'll finish up the last two examples on tomorrow. But this is a lot at one time, I know. Oh, this one looks awful, doesn't it? Okay. Okay, that's all right. We're going to approach it with the same mindset that we had before. We can do this. Remember, you got your math cheerleader mama right here. Mama math cheerleader is right here. Mama Meadows. We're going to get through this. Carry on my back. We got it. All right, so put your identities. And now I'm going to say, okay, we're going to do a 2-column proof. And this is going to be so much fun. I can't wait. Yes. Awesome. Okay. Which side looks the worst? Equally awful? I think the left side looks the worst because it has a what? It's got a division. It's got a fraction. Okay? My notes this morning, I did it one way. You could do these problems a bunch of ways. You can do these problems a bunch of ways. Some of you will see a step that you want to start with. Some of you won't see that step. You want to start a different way. It's just a matter of how you want to start. But what did I tell you guys? Don't ever what? Don't stop. Okay? You could start with getting rid of that denominator on the left-hand side. You could start that way. I'm not going to start that way just yet. I want to see if I can simplify. What are our two most basic functions we said? Cosine and sine. Do I already have cosines and sines on the left-hand side? Okay, so I'm going to leave it. I'm going to rewrite cosine u as cosine x because last problem when I did this, my u became a 4 and I couldn't figure out where a 4 came from and then I realized it was a u. So we're going to go with x. All right, so then I have 1 minus the sine of x. Okay, let's just leave that for a second. Now on the right-hand side, use your identities. What can you change secant into? Good. See, you're already starting to see stuff. 1 over cosine of x plus, what can I change tangent into? Sine x over cosine of x. Perfect. All right. Now, what do you notice? What happened here? Oh, wonderful. They have the same denominator. We like that. That means we can just write this as 1 plus the sine of x. Right? And I can write this one over here as cosine x over 1 minus sine of x. Now, I know you guys are looking at this like, okay, now what? I know it doesn't seem like it, but you guys have simplified this a little bit because do these look similar? Yeah, somebody last period is like, can you just flip one of them? It would be nice if you could do that, but we can't just flip. I would love to just be like, yeah, flip and cross everything out. It's fine. It doesn't work that way. Remember, there's an equal sign right here. All right, so now we got to think. What can we do? All right, let's have a little sidebar. Let's talk for a second. Do you guys remember when we had like 4 over 3 plus 2i? And we're like, we can't have i's in the denominator. How did I get rid of that I? Does anybody remember? What did we multiply by? If you don't remember the word, tell me the number that I would multiply by, or numbers. Anybody? 3 what? Not plus. 3 minus. That was the conjugate, remember? Because now this is the difference of perfect squares. And when I multiply, 3 times 3 is 9. Then I'd have minus 6i plus 6i, right? And that would cancel out in the middle. So same thing, we want to get rid of this fraction. So what is the conjugate? Whenever you have a fraction that's not squared, you just multiply by the conjugate. What's the conjugate of 1 minus sine of x? 1 plus the sine of x, okay? What you do to the bottom, you do where? To the top, okay? Stay with me, you guys are doing great. So, in the numerator, I'm just going to rewrite the numerator. I'm not going to worry about distributing. Because remember, we're simplifying. Things are going to get smaller. They're going to go away. So I'm just going to rewrite cosine x times 1 plus the sine of x. Just let it sit there for a second. Now we're going to FOIL the denominator. What is 1 times 1? 1. What is 1 times negative sine x? Minus sine x. What's 1 times positive sine x? Positive sine x. And then what's sine times sine? Sine squared. So I have minus sine squared x. Now, what do you guys notice happens with the minus sign and the plus sign? They cancel out. Good. So I'm left with 1 minus sine squared x on the bottom. Okay, I haven't even looked at the right-hand side yet. We will in a second. Or you can if you want to. Don't worry about it right now. Okay, now, if I'm going to simplify this. You guys see anything? Do you see a function that is squared? And do you see a plus or minus 1? In red, do you guys see a function that is squared, a trig function that's squared, and a plus or a minus 1? Yes? Do you see that? All right, so where should your eyes go on your identity sheet? To the Pythagorean identities? And Bryn's saying, oh, the first one. I'll tell you guys, we're going to use that first one a whole lot. Because this says sine squared x plus cosine squared x equals 1. What can I do to that purple equation so it says 1 minus sine squared x? I could subtract the sine, correct? So when I rewrite this, it says cosine squared x equals 1 minus sine squared x. So, ladies and gents, do you see how this and this are the same thing now? So what can I replace 1 minus sine squared with? Cosine squared, right? So I'm going to leave the top, cosine x, 1 plus sine x, and then I have cosine squared on the bottom. When I have cosine squared, how many cosines is that really? 2, right? I got a cosine times a cosine. Anybody see anything? What do you see? What do we see? Anybody? I have one cosine on the top and I have 2 on the bottom. Can I do what? I can, yeah, absolutely. There's 1 on top, 1 on the bottom. So 1 on top crosses out with 1 on the bottom. So on the left-hand side, I'm left with 1 plus sine of x over cosine of x. Is there really anything else you guys can do to simplify here? It's not squared on top, so I can't use a Pythagorean identity. Sine and cosine, that's pretty basic. All right, let's go up to the right-hand side and see what we got. Oh, wait a second. What do we have? It's the exact same thing, isn't it? Do they equal each other? They do, yes. You guys just proved that. All right, now, is it much easier as I sit here and guide you? Absolutely, absolutely. But after we do this 1,900 times, I promise you'll start to see things that are a little easier. You guys are always going to ask for suggestions. One of my suggestions to you is if you start off with a denominator, listen to what I'm saying. You start off with a denominator that has a plus or a minus 1, but the trig function is not squared. If it was squared, you could use that Pythagorean identity. But if you start off with a denominator that has a trig function and a plus or minus 1, and that trig function is not squared, the first thing I personally would do is this step right here. I would multiply by the conjugate. Because every time you do that, in this lovely verifying trig identities, it'll work out to where this, once you FOIL it out, becomes one of those Pythagorean identities. Makes your life a little easier. But if you don't see it, like we didn't see that on this one when we first started, that's why you guys didn't see it, so we went a different route, but we got to the same answer. But the more we practice this, I promise you the easier it'll get. I promise, promise, promise. Okay? Okay, so this is the same as yesterday. We're going through and we're going to prove. That means one side has to say this equals this, has to be the same. All right, now there's a couple different ways to do this one. I've done it 3 different ways this morning, just working it out. So we'll see however it takes us. But the first thing we need to do, remember, is to put our trig identities right by us so we can see. All right, we're going to keep referring to these trig identities. You should have them right in front of you. So if I'm looking at this first problem here, which side looks more complicated? Don't tell me both. Which side looks a little more complicated than the other one? I'd say the right side. Good. Why would you guys say the right side? Okay, because it's got tangent. All right, that's a good one, because our most basic are sine and cosine. Another reason I think it's the most complicated is because the denominator has 2 terms. Do you see how the one on the left has only 1 term? It's just cosine. The one on the right has a term and a minus. So I told you guys yesterday, if you have a trig function that is squared with a plus or minus 1, you need to look right at the Pythagorean identities. But when I look at this, the secant minus 1 is not squared. So one of the problems we did yesterday, I said the first thing you might want to do is just get rid of that denominator. We want to simplify. We're trying to get rid of that denominator. What did we do yesterday to get rid of the denominator? You multiplied by the what? Anybody remember? The conjugate. Good, Emma. So secant theta plus 1. What you do to the bottom, you have to do where? To the top. Okay, so we're going to do that. So I'm going to just rewrite the top. Tangent squared theta times secant theta plus 1. I'm not going to do anything with that. And then I'm going to FOIL the bottom. What is secant times secant? secant squared. Then I have secant times 1 gives me secant. Then I have a negative 1 times secant gives me negative secant. What happens to those two things? They cancel. That's why we do that. And then I have a negative 1 and a positive 1 gives me minus 1. All right, now the reason we did that, guys, the reason we did that is because we are trying to create a Pythagorean identity. We're trying to get things to simplify. I'm not even going to touch anything on the left-hand side yet. But if I look at my identities, is there a Pythagorean identity that has a secant squared and a 1 in it? This one, right? Can I do something to the one I just circled in blue to where it says secant squared minus 1? If I subtracted the 1, right? If I move 1 to the other side, that says tangent squared of x equals secant squared minus 1. So what can I replace this secant squared minus 1 with? What trig function? Tangent squared. Good. So I'm going to rewrite this as tangent squared of theta times secant theta plus 1 over tangent squared theta. Now we could go and we could change tangent into sine over cosine. But what do you guys notice? What do we have on the top and the bottom that is exactly the same? Tangent squared of theta. So what can I do? I can cross it out. So I'm left over here with secant theta plus 1. All right, let's go back to the other side. This was 1 plus cosine theta over cosine. All right, so now you guys are like, well, it's still not the same. All right, well, what are our most basic trig functions? Remind me again. Sine and cosine. All right, so on the left-hand side, I'm in sines and cosines. What about the right-hand side? How can I rewrite secant? I can write this as 1 over cosine of theta plus 1, right? Because I still have that 1 there. Yes or no? All right, do you guys agree this is 1 over 1? We have to add fractions. How do you add fractions? You have to get a what first? A common denominator. What's a common denominator, ladies and gents, between cosine and 1? Cosine theta. Good. Very good. So this first fraction has the cosine, so I don't need to multiply anything. I can just put the 1 there. The second fraction has the 1. What do I need to multiply the denominator by so it's a cosine? What do I need to multiply this 1 by so it says cosine theta? Yep. What you do to the bottom, you do where? Perfect. What'd you guys just do? Are they the same? Yes, they are. Very good. Now, again, there is a couple other ways to go through that. But remember, guys, the answer is not 1 plus cosine theta over cosine theta equals 1 plus cosine theta or cosine theta. The answer is this meat in here. And there's a bunch of different ways you could have done it. You could have changed cosines into sine, cosine and sine, tangent into cosine sines. You could have left secant minus 1 underneath. Miss Glick did it a different way, but she got to the same answer. What I'm showing you is, you guys, it's a puzzle. You have to always, always, always try something. Don't just stop. Don't just say this one doesn't work. It does work, I promise you. I'll do this last one and then we're done. Super easy. What does it mean to substitute? To switch out, okay? So this problem says substitute sine of theta for x in the expression and then simplify. So I'm going to say I have 1, and then instead of x, I'm going to put sine, right? You guys see? All I did was just replace this x right here with sine of theta. So I have 1 minus sine squared theta. When you guys see 1 minus sine squared, what does that make you think of? What's a Pythagorean identity that has a 1 and a sine squared? The first one, the one that we've talked about in almost every problem, right? Sine squared x plus cosine squared of x equals 1. All right, how can I manipulate this formula so it says 1 minus sine squared? minus the sine squared. Good. So cosine squared x equals 1 minus sine squared. So if we are simplifying, guys, what can I replace underneath here? What can I replace 1 minus sine squared with? Perfect. So as I simplify this, I have the square root of cosine squared of theta. What would happen here? What would I be left with? I have the square root of cosine squared. Just cosine. Perfect. All you simplify to is cosine of theta. Good job, Alexa. Good job. And that is it, guys. That's 7.1. So the practice that I put up is just you guys figuring out these puzzles, simplifying, proving, trying to make one side look like the other. It's not going to be due until the end of the class period on Monday. I'm going to go through every single problem with you step by step. I'll do it on a video so you guys know what's going on. But you're going to turn it in at the end of class because then you're going to have some practice on your own that I'm going to give you Monday night. That's going to be due Wednesday. We're going to go over that, and then we're going to have our quiz on Thursday. So anybody have any questions?